This is Magic Vision, a Magic the Gathering card price tool. My name is Oscar Romero. I'm a software engineer enrolled at launchschool.com with a Ruby focus. I'm a maker and destroyer. I have made a PC, a Hackintosh. I have a couple of Arduinos and Raspberry Pi. Love LEDs and have a 3D printer. I also like taking apart electronics and building speakers and subwoofers. And I'm also a sci-fi and fantasy nerd. I enjoy playing Dungeons and Dragons and reading fantasy novels. I enjoy learning and I'm looking for opportunities to learn and grow with others. So the problem is you decided to learn Magic the Gathering. You spend a lot of money on card packs and have a ton of duplicate cards. Worse, you don't even have a card that you want or need. Magic the Gathering is big money. $50,000 for first place and $250,000 for total cash prize. So if you want second, anywhere from second to fifth place, I believe, and a couple other positions. So solution, Magic Vision, of course. You text a photo of a card, and Magic Vision will respond with a cleaned up photo, current market price, and a link to buy or sell that card. The technologies that power Magic Vision stand on three main pillars. First, we start with the Twilio API, then the Microsoft Azure API, the Computer Vision API, and Scryfall API. So when we send an image via text message, that media URL is sent via webhook to the Azure function. Within there, we forward it and call the read API, which does analysis of text and in photos. Once that analysis is complete, we return the analysis and parse out the card title. Then we send that title to the Scryfall API and query that title. The Scryfall API is a large database of Magic the Gathering card information, from prices to card text to legalities of card plays and tournament. So once we call that API, we return all relevant card information. Within the function, we parse out the image, price, and link, and then just send that back via text message to the Magic Vision. Excuse me. So let's start out with the technologies behind Magic Vision. We have our node packages like Node Fetch, which provides an interface for getting HTTP resources with methods like get and post and the appropriate response. And then we have Query String, which allows us to parse a string into a collection of key value pairs. And then the Twilio package, which just pretty much creates a library of functions to interface with the Twilio API. Technologies. We're going to review our code base right now, and we'll start off with the setup, where we have our constants, our required packages, endpoints, and key, and define a sync delay function. So you can see here we have Node Fetch, Query String, and Twilio. TWIML is a markup language developed by Twilio to handle their message response. Then we call the Magic Vision Cognitive API, which does the actual text analysis. And we have our Scryfall API. As you can see here, you can notice the fuzzy equals. This allows us to call the Scryfall API and provide a name where we're not exactly sure of the card title, which is nice in case we return a text that's not quite as accurate as the card name. And then we have our key, which allows us access to the cognitive service. Our delay just takes the difference between two timestamps and takes the parameters milliseconds. Technologies. We'll start off with the Twilio part. It's pretty simple here. We parse the URL from the request body and then just initialize the image URL to a variable. We have a context log that just outputs image sent via Twilio to the Azure function. We'll follow up with computer vision part, where we fetch the computer vision API with a post method where we post the image URL, and you can see here that needs to be in a JSON string format. So we use JSON stringify to put that in the correct format. And then we supply the key to provide access to that function. Then when we return the response, and we just get the operational location where which pretty much is the URL where that analysis took place. Then we follow it with a get method to get that required analysis. And it's pretty much using that URL from before. This required an iteration due to the delay in running that analysis. My first implementation wasn't working because it would fetch the analysis right after we submitted it, and so I was getting no text back. And another solution that I found created new promises, and that was creating issues with the Twilio response message. So this sync delay of 2 milliseconds seemed to work best for my needs. So we iterate over that 5 times, and then we break out of there if the read status has succeeded. That's pretty much it. Once we return information, then we can just parse out the most likely card title from the response, which is usually the first line of text, and we just output that out into the Azure function. Once we have the card title, we use that to fetch the Scryfall API and pass in that card name with that fuzzy search from before. And then once we get a response, we get all the relevant card information, just parse out the card information, including image, purchase price, and we have a purchase price for a foil card. A foil card is a card that has like a shiny foil on it. So it kind of looks holographic and shiny, so it's just worth more. And we have a conditional here. If the price is null or returns no price, we just return 0. For example, a card might not have a foil version, so there is no price, foil price, or the inverse. There's no normal version of that card, and we only have foil versions of that card, and so that's why that conditional is there. Then we just close out with the second part of Twilio. So once we parse out that information, we just send that with the node package, the Twilio node package, and send a response message back to Twilio, Magic Vision. And that closes out the code base. Here's a product demo of the front end, me interacting with the phone in Magic Vision. Okay, so here I am taking a photo of a Magic the Gathering card that I bought last night. Take a picture, try to make sure there's no additional text that might confuse the read API. This is being sent via Twilio to Azure function, and then we're calling the Scryfall API. So and waiting for that read analysis to take place. So it just takes a little time to get information returned. So please wait with me. I'm going to speed this up actually. Okay, so here we returned the card image with a market price and a link to buy it. I believe the specific one is a foil, so it's worth about 12 cents. It's a brand new card. So now I'm going to try submitting an image that I took online of a card, and I believe this card format only has a foil version. So we're sending it out and just waiting for the analysis to be performed. Okay. Perfect. We return the card price, and as you can see, normal is 0 and the foil price is $62. It only comes in foil version. You can buy it online, and you can see there for $62 or $72. And that's pretty much it for the front end. Product demo. So this is a the backend, so the serverless function that's hosted on Azure code base. So when we submit that image, this is what's happening in the cloud. I'm just setting up so you can see the log, and I'm submitting an image right now for analysis. One moment, and there we go. So we're executing the function. Get the image. You can see the iteration taking place right here. This large body of information is card info, and then we just parse out the card information and send that back via text message. And that's it. Improvements. I want to better handle errors. One of the issues that I had is making sure that the image is in the correct format. The computer vision AI only uses JPEGs or PNGs, and the iOS phone can output to JPEG, but that seems to be only working when in portrait mode. Excuse me. And so I just need to write code to handle that better. Twilio has an error if the image is not in the correct format, but then also Azure throws an error depending on what it fetches. So I just need to figure out where to handle that error. I would like to refactor the code just to get rid of extra lines of code, especially when we parse out the card information that could probably be handled in an array and just iterate over the array. It'll be nice to separate the functions. So create two functions, one for Twilio and one for the computer vision AI, and then have the Twilio function reference the computer vision AI. I would also like to create a user history so we can track all the history of the user and trend prices and create a website of all the scanned cards for future reference. And then I want to follow up with my experience as a bid project. I had an unforgettable time with bid project. Magic Vision was built with skills I learned, including JavaScript, Node Package Manager, Azure Functions, REST APIs, and Twilio. These were all technologies that were new to me. I've heard of them, but I've never used them before. And in this short time, I was able to create something that you see here today. I also enjoy the professional series of videos where we had examples like acing the technical interview and preparing your resume and LinkedIn profile for job search. For someone like me who's trying to get into tech, that was invaluable. I also enjoyed making new friends. We bonded over a lot of experiences getting our code to work and learning from each other. If I had a question, somebody would help me, and if I knew an answer, then I would help them. I also love making relationships with tech people, like my mentor, Nika Fee. I'm not a tech person. I'm trying to transition into tech. And so those relationships are worth their weight in gold. Also I hate banging my head over GitHub merge issues. But it was invaluable also because I've only used GitHub to post my code to a repository. Within Bit Project, we used a working code base with multiple branches and multiple people submitting to that code base. So just dealing and learning how to handle all those errors was very valuable. And then yelling like band fans when our code works. So I just want to thank everybody, especially the Bit Project team, for all their help in setting this up. My mentor, Nika Fee, for all her advice and help with my personal growth, and my peers. I had a great time, and so thank you.